Alright, linear regression. Linear regression can be summed up with a simple equation. How do you like that? Simple. Okay, so this is the simple equation. And it's basically, it's the sum of the x times the y. So the sum of the product of the coordinates, right? Of each coordinate. So the x times y, 1, and the x sub 2, y sub 2, and the x sub 3, y sub 3, and however many you have. Minus the sum of the x's times, so minus the quantity of the sum of the x's times the sum of the y's divided by the number of numbers. So how many of them are there, right? How many x's are there? Or how many y's are there? How many coordinates, in other words, are there? All divided by the square root of the quantity. And this quantity right here is the summation of the x's squared. So the summation of the x squares minus the summation of the x's squared. So a little different. Divided by the number of x's, right? Times the sum of the y squared, the sum of all the y squared, minus the sum of the y's squared, divided by the number of y's. Okay? Alright, so now that we got the equation, that simple equation understood.
I don't understand it.
Well, good. Okay, so you don't understand it. Well, you will. Maybe.
You will.
If you want to pass this class. Okay, so here's your x's and your y's. And the thing is, I'm going to show you is how, like I did before, we made tables out of everything, right? Keep that whole table thought when we're making these. So my x's and my y's are quite simple. It's just 3, 1, and 2. -4, 0, and -5. Now obviously, we could have a lot more numbers, right?
Yeah.
Like we've seen in the last problem where we had all those red dots. I mean, plugging all those into this equation would be really tough. That's why we built computers. And they'll do it for us. But the point is we need to understand what they're doing. Okay? So, and sometimes you do have to do this by hand. Usually only for certain math classics where you have a sadistic teacher like myself telling you you have to do it by hand. Or biology teachers, chemistry teachers, botany teachers, that you have to find the linear regression. A lot of times though they let you just do it with your calculator and you plug in these points and it gives you the answer. Blink. But this is how the computer or your calculator does it. Okay? So our first step is to create some things. So one thing I like to look at is, how about like, it asks me for the product of x times y, right? So let's make an area where we have the products of x times y. And that's really easy. It's just this times this, which is -12. Or this times this, which is 0. Or this times this, which is -10. So that's easy. What else do I need? So let's label everything we need. We need x times y. We need the sum of the x's. We need the sum of the y's. We also need the sum of the x's squared and the sum of the y's squared. But we also need the sum of the x's squared and the sum of the y's squared. Right? Oh, one other thing. We need n. We need to know n. Oh, by the way, n is not 6 in this case. Yes. n is 3. Remember, n is the number of coordinates, not the number of x's and y's. It's really just the number of x's or the number of y's. So, or think of it as the coordinates. 3, -4, 1, 0, and 2, -5. So how many points are there, in other words? There's 1, 2, 3 points. And so we're going to find this linear regression that goes with the 3 points. Okay, so in this case, n is 3. So that's nice to know. Okay? We figured out the x times y, right? So what's next is maybe figuring out, hey, here's a nice way to look at it. The sum of the x's, right? And the sum of the y's. So instead, let's look at it as the sum of the x's and the sum of the y's, right? Because now, oops, a little big, right? So now all I have to do is say, what's 3 plus 1
6
plus 2?
-9.
And that's 5, 6, and -9. Okay. Oh, what's a cool one to find out after that one?
EX squared.
Yeah. So
36.
So
-81.
yeah. So now we have the sum of the x's squared and the sum of the y's squared. Okay. So that's a good one to figure out.
36 -81.
Yeah, so that's easy, right? 36 and not -81. 81. -9 times -9 is 81. Okay? And that's recording, right? It's
Yeah.
Brad? Okay.
I hope so.
Me too, because this is like,
Yeah.
this is going to be pretty good. Okay, so now some other things we need to know.
EX squared.
Yeah. So here are some things. How about, I need to know the squares, right? So I need to know my x squared and my y squared, right? So I need to know x squared is 9, x squared is 1, x squared is 4. Make sense? Y squared is 16, y squared is 0, and this y squared is 25. Okay? And then I can write my sum of the x squares, right? I'll put that at the top. Sum of the x squares, right? And the sum of my y squares. So now all I have to do is add those numbers up. 9 and 1 is 10 plus 4 is 14. 16 and 0 is 16 plus 25 is 31, 41. Does that make sense? Oh shit. Shoot. This is the actual problem though for you guys, huh?
Oh no.
No, it's not.
Yeah. It is.
It's not.
How is that possible? I gave you the notes for it.
Take the paper.
Because I didn't take the next set of notes, which was I just started doing the top problem,
So
which
you
is
might
the
as well
actual
give us the
problem.
answer.
Christmas is early.
We'll have to make up a new problem for your test.
What?
So, because I
Why
want
don't
to
you
finish
erase
this,
this real
right?
quick then?
Huh? Just erase this real quick. I'm recording it. We're doing such a good job with it, right?
I don't want to do an extra problem.
You'd have to do it anyways.
Not really.
So we'll give you the problem that's actually our practice problem as the problem, and our real problem is the practice problem. Big deal. Okay, so here we go. So we just plug it in. That's all that's left. So the key here is creating this format, right?
That grid.
That grid that gives you everything you need. We have the xy's. We have the sum of the x's. We have the sum of the y's. We have the sum of the x's squared. We have the sum of the y's squared. We have the sum of the x's squared. We have the sum of the y's squared, right? The difference being this is the x's squared and then the adding them up. And this is the adding them up and then squaring it, right? So that's really important. Now we just plug it into the formula. So r is equal to the sum of the x times the y. Well, the sum of the x times the y, oh, we didn't find that. We just found x times y. So now we need to know the sum of the x times the y. And that's really easy to do because it's just this plus this, which is negative 22. Okay? So that's not bad. So we got negative 22